Imagine a world that covers more than 60% of our planet, yet remains largely uncharted and unseen by human eyes. This is the deep ocean, a vast expanse that harbors unimaginable secrets and stories waiting to be uncovered. Beneath the waves lies a realm of dark, forbidding depths, where the pressure is crushing and sunlight never penetrates. Yet, it's in this very realm that some of the most extraordinary discoveries have been made, presenting a tapestry of life and geological wonders that challenge our understanding of the natural world. The ocean is divided into several layers, each with unique characteristics, starting from the sunlit surface, which comprises the photic zone, down through the twilight zone to the abyssal and hadal zones. Each layer is teeming with life and has its own mysteries. Developing technologies have allowed researchers to explore these depths, yielding astonishing results. In fact, according to the National Oceanic and Atmospheric Administration, over 95% of the ocean remains unexplored, an ongoing frontier for scientists. In the early 1960s, humans first ventured into the abyss with the bathyscaphe Trieste, which reached the depths of the Mariana Trench, the deepest part of the world's oceans. This bold expedition uncovered the strange realities of life at extreme depths. What they found, along with subsequent missions, is a world where species have adapted in ways that defy our expectations. From giant squids with eyes the size of dinner plates to vibrant ecosystems around hydrothermal vents, the discoveries have been transformational. Take, for example, the hydrothermal vent communities, where life flourishes from chemosynthesis rather than photosynthesis. These vents release superheated, mineral-rich water from the Earth's crust, creating an oasis in total darkness. Organisms such as tube worms, giant clams, and specialized bacteria thrive in these extreme conditions, rewriting the rules of biology. What surprises await us as technology advances, and we dig deeper into the ocean's mysteries? The journey into exploring the deep ocean has only just begun. The data collected from deep-sea dives and explorations widen our eyes to the unknown mysteries existing beneath the ocean's surface. As we venture further, we will also confront the urgent crises affecting these ecosystems. Just imagine, with every dive, we could find species that haven't yet been documented, or ecosystems that could provide insights into climate change. Will we be able to protect what we find before it's too late? The urgency of exploration drives home the importance of understanding these hidden realms. Now, let's journey deeper into the ocean, where the true wonders and mysteries await. As we journey deeper into the ocean, we encounter bizarre and otherworldly creatures that seem to have emerged from a science fiction novel. The deep ocean is home to a plethora of life forms that have adapted to survive in extreme conditions, leading to fascinating evolutionary characteristics. From the anglerfish with its bioluminescent lure to the ethereal jellyfish, these creatures reveal nature's creativity and resourcefulness. One of the most iconic creatures of the deep is the anglerfish. With its bioluminescent lure dangling from its forehead, this predator attracts unsuspecting prey in the dark abyss. Its eerie appearance, complete with sharp teeth and a large mouth, has made it a staple of deep-sea lore. But what many don't realize is that the anglerfish's mating habits are even stranger. The male anglerfish is tiny in comparison and becomes a permanent parasite on the female, fusing to her body and sharing her nutrients. This shocking adaptation underscores the bizarre and extreme conditions that drive evolution in the deep sea. As scientists explore further, they often find creatures that challenge what we know about biology. For instance, the blobfish has become a symbol of the deep sea. Often referred to as the Imagine a place where superheated, mineral-rich water gushes from the ocean floor, creating an oasis of unique life, thriving in the absolute darkness. Welcome to hydrothermal vents, the underwater volcanoes that reveal the Earth's secrets and support distinctive ecosystems. These vents are not just fascinating geological formations, they are life-giving sources in the abyss. Discovered in 1977 along the Galapagos Rift, hydrothermal vents reshaped our understanding of life's origins on Earth. The extreme conditions surrounding these vents, including high temperatures and pressures, forge a unique environment that supports a vast array of organisms that thrive without sunlight. Instead of relying on photosynthesis like surface organisms, life here relies on chemosynthesis, a process that converts chemicals released from the Earth's crust into energy. The primary inhabitants of these vents are extremophiles, organisms that have adapted to survive in extreme conditions. Giant tube worms, for instance, can grow up to 8 feet long and contain symbiotic bacteria that perform chemosynthesis, allowing them to live where no light penetrates. These ecosystems around hydrothermal vents exemplify the incredible resilience of life, prompting scientists to reconsider how life may exist on other celestial bodies. As researchers continue to study these unique environments, they have made remarkable discoveries, including the presence of new species of crabs, shrimp, and even new types of bacteria that can withstand temperatures exceeding 400 degrees Fahrenheit. What does this mean for our understanding of life's adaptability? As we explore more vents, what other surprises might we uncover? The significance of hydrothermal vents extends beyond planetary exploration. They also hold clues to understanding Earth's geological processes. The minerals emitted from these vents play a crucial role in ocean chemistry and contribute to the oceanic food web. As we face climate change and environmental challenges, the preservation of these delicate ecosystems becomes increasingly vital. As we venture further into the abyss, we will uncover more astonishing truths that could change our understanding of life itself. Dive into the mystical world of bioluminescence, one of the most enchanting phenomena of the deep ocean. Bioluminescent organisms produce and emit light through chemical reactions in their bodies, creating a dazzling display against the darkness of the deep sea. This light serves a variety of purposes, from attracting mates to deceiving predators. It's estimated that over 80% of deep-sea creatures exhibit some form of bioluminescence, making it a prevalent feature in these dark waters. Among the most striking bioluminescent creatures is the jellyfish. These translucent beings emit a mesmerizing glow, captivating scientists and explorers alike. Known for their ethereal beauty, jellyfish also utilize their glow to evade predators and lure prey. The mesmerizing glow of these creatures raises questions about the evolutionary advantages provided by bioluminescence. Another fascinating example is the deep-sea anglerfish, which uses its bioluminescent lure to attract unsuspecting prey. As light functions as a beacon in the pitch-black environment, the anglerfish showcases nature's remarkable strategies for survival. Several species of plankton also possess this attribute. Known as dinoflagellates, they create a stunning display of light when disturbed, leading to breathtaking phenomena like glowing waves. The science behind bioluminescence is complex and has fascinated researchers for decades. Scientists study the chemical reactions that produce light, investigating the potential applications of bioluminescence in technology, medicine, and environmental monitoring. By understanding how these organisms emit light, we may unlock new technologies ranging from sustainable lighting to advanced medical imaging techniques. As we marvel at the beauty and utility of bioluminescence, we can't help but ponder its implications for our understanding of life beyond Earth. If life can thrive in total darkness and create its own light, what might we find in the oceans of other planets or moons, such as Europa or Enceladus? The mysteries of bioluminescence point to the resilience and adaptability of life, urging us to explore and protect these hidden wonders. As we dive deeper into the ocean, we reach a realm that remains shrouded in mystery and intrigue, the deep-sea trenches. These trenches, often referred to as the ocean's deep canyons, are some of the most extreme environments on Earth. The Mariana Trench, the deepest known point on the planet, plunges over 36,000 feet, and it can hold secrets that challenge our understanding of biology, geology, and even the potential for extraterrestrial life. In the last few decades, the exploration of deep-sea trenches has provided astonishing insights into life at extreme depths. During the 2012 dive of James Cameron in the Deep-Sea Challenger, new species were identified, including the remarkable snailfish, which holds the record for the deepest fish ever discovered. These organisms exhibit unique adaptations that allow them to thrive under immense pressure, where few other life forms can survive. The environments they inhabit reveal how life can adapt to even the most inhospitable conditions. The trenches are not only home to bizarre animals but also play a crucial role in our planet's geology. These deep canyons are formed by tectonic plate subduction, a process that reshapes the Earth's crust. They also serve as significant carbon sinks, absorbing carbon dioxide from the atmosphere and impacting global climate patterns. Understanding the functionality of these trenches provides invaluable data about Earth's climate system. With advancements in remote-operated vehicles and deep-sea submersibles, we can begin to unravel the mysteries of these trenches. Each dive brings new discoveries that change our perception of the oceanic ecosystem and its complexities. However, the exploration of these depths raises ethical questions about conservation and the preservation of these pristine environments. How do we balance exploration with the responsibility of protecting these delicate ecosystems? The journey into the deep-sea trenches will continue to challenge our understanding of life on Earth and beyond. As we venture further, what revelations will we uncover? The quest for exploration is just beginning, and the secrets of the deep remain tantalizingly close yet frustratingly out of reach. As we explore the ocean's depths, we inevitably stumble upon the echoes of human history submerged beneath the waves. Shipwrecks represent not merely the remains of vessels lost to storms or conflict, but stories waiting to be uncovered. One of the most notorious shipwrecks, the RMS Titanic, rests more than 12,000 feet below the surface, a grave for over 1,500 souls, and a testament to human ambition and tragedy. The Titanic sank on April 15, 1912, after hitting an iceberg on its maiden voyage from Southampton to New York. For decades, it remained shrouded in mystery until a groundbreaking expedition in 1985 revealed its resting place, igniting a wave of interest in shipwreck exploration. But the Titanic is just one among thousands of wrecks littering the ocean floors. In the Caribbean Sea, the sunken Spanish galleon Nuestra Señora de Atocha, lost in a hurricane in 1622, carried treasure worth an estimated $400 million. Treasure hunter Mel Fisher spent 16 years searching for it, ultimately discovering it in 1985, uncovering gold, silver, and emeralds. This discovery not only highlighted the ocean's role as a keeper of our history but also sparked debates about the ethics of treasure hunting. Should treasures be pulled from their watery graves, or should they serve as monuments to our past? These shipwrecks are not merely vessels of human ambition but also havens for marine life. Coral reefs and diverse species make these submerged skeletons their homes, creating unique ecosystems. A study by the University of Delaware confirmed that shipwrecks can support up to 300 species of fish, providing essential habitats. Shipwrecks like the USS Monitor, a Civil War-era shipwreck, became artificial reefs, enriching biodiversity and serving as a reminder of our maritime history. Yet, as we uncover these poignant stories, we must grapple with the implications of our discoveries. Wrecks are often viewed as both archaeological sites and resource pools, which leads to conflicts over preservation versus exploitation. The Oceanographic Institute in San Diego emphasizes the need for responsible exploration that honors the cultural significance of these sites. As technology advances, more wrecks come into view. The discovery of the USS Houston, lost during World War II, illustrates not just the tragedy of loss but also the importance of commemorating those who perished. As we delve deeper into the ocean's depths, are we ready to face the human narratives held captive in these sunken vessels? The mystery of the deep has so much more to tell us, and as we push our exploratory boundaries, we ensure that the voices of the past resonate through time. What other stories lie obscured beneath the surface? Imagine descending into the deep ocean, where sunlight can't penetrate and life thrives in ways we can barely comprehend. Deep-sea expeditions have become vital for understanding our planet's last uncharted territory. One of the most notable missions was the 2012 Deep-Sea Challenger expedition, where filmmaker James Cameron piloted a specially designed submersible to the Challenger Deep, the deepest point on Earth. At nearly 7 miles deep, the Challenger Deep is a realm of extreme pressure and darkness. Cameron's journey lasted around 3 hours, during which he collected valuable data that would contribute to our understanding of the abyss. He documented some previously unknown organisms and geological formations. But Cameron's mission was just one piece of the puzzle. Organizations like NOAA, National Oceanic and Atmospheric Administration, have been at the forefront of ocean exploration. Their Volcanoes Explorer vessel operates the only federally funded ship dedicated to exploring the deep sea, using remotely operated vehicles, ROVs, equipped with high-resolution cameras. This approach allows scientists to gather real-time data while minimizing human presence, safeguarding delicate ecosystems. In 2020, the Volcanoes Explorer completed a mission mapping the Mariana Trench, revealing remarkable biodiversity, including previously unidentified sponge species. This revelation underscores how much we still have to learn about the deep ocean's ecosystems. Each expedition serves to uncover not only new species but also the impacts of climate change, human activity, and pollution. Research indicates that deep-sea creatures are increasingly affected by plastic waste, with studies showing microplastics in the stomachs of deep-sea fish. The science of deep-sea exploration is still in its infancy. While we have explored only about 20% of the ocean, the remaining 80% holds mysteries beyond our imagination. One fascinating aspect uncovered through exploration is the phenomenon of underwater lakes, often termed brine pools. These pools are denser than surrounding seawater and host distinct ecosystems of life adapted to extreme conditions. Studies have shown that species living in these pools often differ significantly from those in the surrounding environments. As we continue to explore, we must also emphasize the role of technology. Autonomous underwater vehicles, AUVs, are revolutionizing deep-sea research. Equipped with sensors and cameras, these AUVs can autonomously map vast areas of the seafloor, vastly enhancing our understanding of marine topography. Researchers employed AUVs during the 2016 Ocean Exploration Trust mission, revealing never-before-seen volcanic formations, further contributing to our ever-expanding knowledge. As we look toward the future, the question remains, how will we balance the quest for knowledge with the need to protect these vulnerable ecosystems? In the unexplored depths of the ocean, every discovery holds the potential to change our perception of life on Earth. The stories we uncover now could provide insights that influence how we view our planet and our responsibilities towards it. As we descend deeper into the ocean, we encounter not only wonders but also the harsh realities of our time: climate change. The ocean is a vital component of our planet's ecosystem, absorbing nearly 30% of the carbon dioxide produced by human activities, which leads to increased acidity. This phenomenon affects marine life at all levels, from coral reefs, the rainforests of the sea, to the giant whales that roam the depths. Coral reefs, in particular, are highly sensitive to changes in temperature. The Great Barrier Reef, one of the most significant ecosystems on Earth, has witnessed mass bleaching events in recent years due to rising sea temperatures. Studies show that over half of the corals in this ecosystem have died in the past few decades. This loss not only impacts marine biodiversity but also threatens the livelihoods of millions who depend on reef health for fishing and tourism. The implications of these changes stretch beyond the oceans, affecting food security and economies globally. In the deep sea, the effects become more complex. Warmer waters lead to altered currents, which can shift the distribution of fish populations and impact food webs. Research indicates that certain fish species migrate towards colder waters, leading to potential imbalances in ecosystem dynamics. Furthermore, the melting of polar ice caps and glaciers contributes to rising sea levels, threatening coastal communities worldwide. The Arctic Ocean is warming twice as fast as the rest of the planet, leading to the loss of critical habitats for species like polar bears and seals. Ironically, this warming could also expose underwater habitats to new threats, such as increased shipping traffic and oil drilling, challenging conservation efforts. Through all this, deep-sea ecosystems such as hydrothermal vents and cold seeps serve as crucial indicators of climate change impacts. Research suggests that these unique environments may be at risk due to the changing chemistry of the ocean. As temperatures rise, deeper waters may experience oxygen depletion, stressing organisms adapted to stable conditions. The ongoing investigation into these impacts reveals stark truths. A report by the Intergovernmental Panel on Climate Change warned that if temperatures continue to rise, a significant number of marine species may face extinction. As stewards of the planet, we must look deep beneath the surface and recognize our responsibility to protect these fragile ecosystems. Ultimately, the deep ocean's mysteries intertwine with the most pressing issues of our time. The relationship we have with our oceans shapes the future of life on Earth. Only through understanding and action can we hope to preserve the rich tapestry of life that exists beneath the waves. Looking ahead, the future of deep-sea exploration brims with potential and promise. As technologies advance, we stand on the brink of significant breakthroughs in our understanding of the ocean's mysteries. The next generation of submersibles and AUVs will be crucial in unveiling the deep's secrets. Innovations like AI and machine learning will enable researchers to process enormous amounts of data, making it possible to identify patterns and draw insights about the intricate relationships within marine ecosystems. Collaborative international efforts are essential. Just as the International Space Station brought together countries for space exploration, we need a similar approach for ocean conservation and research. The Ocean Exploration Cooperative Institute, for instance, aims to unite scientists, technologists, and policymakers to foster innovation and address global ocean challenges. Shared knowledge can enhance our collective understanding and ensure that exploration is sustainable and ethical. One exciting possibility on the horizon is the concept of ocean exploration tourism. Imagine being part of a deep-sea expedition, equipped with immersive technology that allows you to experience the beauty of underwater landscapes firsthand. This approach could increase public engagement with ocean conservation while providing a funding source for research initiatives. Companies like OceanGate are already pioneering manned submersible expeditions, bringing ordinary people face-to-face with the wonders of the deep. Moreover, the role of citizen science cannot be understated. Engaging the public through initiatives like the Ocean Observatory's initiative empowers individuals to contribute to data collection and monitoring efforts, enhancing our understanding of marine environments. The collective efforts of everyday people can make significant contributions, fostering a sense of responsibility for our oceans. Yet, amidst our excitement, we must remain vigilant about the threats that our discoveries may bring. As we uncover new species and resources, the potential for exploitation rises. The deep ocean has untapped mineral resources, including precious metals, which have spurred interest from various industries. Ensuring regulations and sustainable practices is vital to prevent irreversible damage to these delicate ecosystems. Looking to the future also means understanding the importance of education and advocacy. Raising awareness about the value of ocean conservation can inspire future generations to protect these ecosystems. Environmental organizations stress the importance of integrating ocean literacy into education systems, ensuring that young minds recognize the ocean's value. As we stand at the precipice of a new era in ocean exploration, our journey into the depths offers a lens into our planet's past, present, and future. The mysteries of the deep hold lessons for humanity, reminding us that the ocean is not merely a resource but a vital component of life on Earth. Our discoveries may change how we view our place in the world, revealing interconnectedness that binds us all together. As we conclude our journey through the deep ocean's vast and mysterious realms, we find ourselves captivated by discoveries that have the power to change everything we know about life on Earth, both scientifically and existentially. Every expedition into the abyss reveals not just new species and ecosystems, but also answers to fundamental questions about our existence. Consider the extremophiles that thrive in the deepest parts of the ocean. Organisms such as the tardigrade, or water bear, are capable of surviving extreme conditions of pressure, temperature, and radiation, fascinating examples of life's resilience. Research has even suggested that studying these creatures could unlock secrets for advances in medicine and biotechnology. Recent studies highlight their potential in space exploration, as they could one day aid in the search for extraterrestrial life. Moreover, the discovery of unknown biochemical processes in deep-sea organisms has significant implications for pharmaceutical research. For example, the potential of deep-sea organisms to produce novel compounds that can fight diseases like cancer and bacterial infections is profoundly promising. Scientists have already begun to extract these compounds for research, opening new avenues in drug discovery that could benefit millions. Then there's the concept of biogeochemical cycles, how life processes influence the flow of energy and nutrients on Earth. Deep-sea ecosystems play a critical role in carbon sequestration, and as we learn more, we unravel the importance of preserving these habitats. By understanding how the ocean affects climate regulation, we can make informed decisions that shape our environmental policies and practices. Furthermore, cultural and philosophical implications arise from our discoveries. As we delve deeper, we confront the notion that life under the sea is as complex, intricate, and beautiful as life on land. This realization urges us to rethink our relationship with the ocean, fostering a deeper appreciation for our planet's biodiversity. The ocean is a vast library of knowledge, telling stories of evolution, adaptation, and survival. With every new species we identify, we add a chapter to this narrative, urging us to consider the ethical dimensions of our exploration. How we treat these ecosystems reflects our values and responsibilities as stewards of the planet. Will we choose to exploit these treasures, or will we prioritize the health of our oceans? As we wrap up this exploration, we invite you to reflect on the significance of the ocean in our lives. The discoveries we've discussed today are merely the surface of what lies beneath. The deep ocean has much yet to reveal, reminding us of the interconnectedness of all life. The more we learn, the more we realize that the quest for knowledge is not just about uncovering secrets but also about nurturing our planet for future generations. Let us move forward with a sense of wonder, responsibility, and hope for the incredible depths still left to explore. What remains hidden beneath the waves could hold the key to our survival, urging us to cherish and protect this blue planet we call home. As we dive deeper into the ocean's mysteries, we uncover not just peculiar marine life but also relics of human history lost to the depths. The ocean floor, often regarded as an untouched museum, holds remnants of sunken cities, ancient shipwrecks, and artifacts that date back millennia. One of the most intriguing discoveries is the remnants of the ancient city of Heracleion, which lay submerged off the coast of Egypt for over 1,000 years. Rediscovered in 2000 by underwater archaeologist Frank Gaudio, the city provides valuable insights into the Greco-Roman world, showcasing large statues and temples that were once part of a bustling trade hub. Heracleion was not alone in its fate. Other underwater ruins, like the sunken city of Dvarka in India, have sparked significant research into the histories of ancient civilizations. The underwater exploration of these sites reveals not just historical artifacts but offers a unique perspective on how climate change and rising sea levels threaten our cultural heritage. Furthermore, the iconic Titanic wreck, discovered in 1985, has been the subject of numerous explorations and documentaries. This tragedy not only immortalized the ship but also reminds us of the ocean's power and the stories that lie within its depths. Presenting an intriguing mixture of history and mystery, the Titanic continues to captivate our imagination, with recent explorations revealing valuable data about marine life inhabiting the wreck. Each of these discoveries challenges our understanding of history and reminds us that the ocean is a vast archive, waiting to be explored. As technologies advance, underwater drones and robotics are being utilized to access deeper and more dangerous parts of the ocean, potentially revealing more secrets about our past. But the ocean is not merely a graveyard of the past, it also serves as an essential component of our planet's climate system. As we uncover these ancient relics, we must also consider the implications of our explorations. How do we balance the urge to explore with the necessity to protect these fragile remnants of history? The answer lies in sustainable practices, ensuring that future generations can learn from and cherish these watery wonders. What other secrets might we unearth as technology evolves and we journey deeper into the unexplored waters? What could these finds teach us about human resilience and the effort to coexist with nature? At the heart of the ocean's ecology lies a hidden world, one that is invisible to the naked eye yet vital for the health of our planet: microbial life. These tiny organisms, including bacteria and archaea, play crucial roles in nutrient cycling, carbon fixation, and the overall functioning of marine ecosystems. Research estimates that there are approximately 1 million microbes in just a single milliliter of seawater, showcasing the staggering diversity that exists in the deep. One captivating story comes from the discovery of oceanic dead zones, areas where oxygen levels are so low that marine life cannot survive. These regions, often caused by nutrient runoff from agriculture and industry, serve as a grim reminder of how human activity can disrupt these delicate ecosystems. Scientists are employing advanced monitoring techniques to track changes in microbial communities within these zones, shedding light on how they can adapt or collapse in response to environmental stressors. Moreover, research into extremophiles, microorganisms that thrive in extreme conditions, has opened new avenues for biotechnology. For instance, scientists have isolated enzymes from deep-sea microbes that are capable of functioning in extreme temperatures and pressures. These enzymes have potential applications in pharmaceuticals, food science, and even biofuels, illustrating how the deep ocean continues to provide untapped resources. Additionally, the role of microbial life in carbon sequestration is gaining attention. By understanding how these microorganisms break down organic matter and fix carbon, researchers are exploring innovative methods to mitigate climate change effects. The implications are profound. Harnessing these natural processes could lead to new strategies for reducing CO2 levels in the atmosphere. As we delve deeper into the microbial world, we realize that these small organisms hold big secrets, keys that could unlock solutions to some of our most pressing environmental challenges. Will we be able to learn how to protect and utilize these microscopic allies? The answers lie beneath the waves, awaiting discovery. The future of ocean exploration is not just about brave adventurers and cutting-edge vessels. It's a revolution in technology that is reshaping how we understand the deep sea. From autonomous underwater vehicles to advanced sonar systems, the tools at our disposal are becoming more sophisticated, enabling us to venture deeper and with greater precision than ever before. One of the standout innovations is the development of autonomous underwater vehicles, or AUVs. Equipped with sensors and cameras, these unmanned craft can traverse depths that were once unreachable, capturing data and images in real time. In 2012, the AUV Sentry played a pivotal role in mapping the Mid-Atlantic Ridge, a crucial underwater mountain range, revealing new geological formations and deep-sea ecosystems. Moreover, remote-operated vehicles, ROVs, have taken exploration to another level. With the ability to dive deep into the ocean while being controlled from the surface, ROVs have uncovered countless discoveries. For example, the exploration of the Challenger Deep, the deepest part of the Mariana Trench, was conducted using the ROV limiting factor. This mission not only achieved the greatest depth ever reached by a human-piloted vehicle but also provided unprecedented insights into the unique biomes located at such extremes. Another remarkable technological advancement is the use of satellite technology to monitor ocean conditions. Satellites can measure ocean temperatures and chlorophyll levels, helping scientists to assess the health of marine ecosystems from space. The data collected is invaluable for understanding climate phenomena like El Niño, which drastically affects global weather patterns. As these technologies evolve, they are enabling even more ambitious projects. The Ocean Exploration Cooperative Institute, for instance, aims to map the entire seafloor by 2030 using a combination of AUVs, ROVs, and satellite data. Such a comprehensive mapping effort could revolutionize our understanding of ocean habitats, allowing for better conservation efforts and a deeper grasp of marine biodiversity. But with each leap in technology comes ethical considerations. How do we balance exploration with conservation? As we uncover more about the ocean's depths, we must also commit to protecting these fragile environments from the potential harms of our activities. What kind of future awaits in marine exploration as we harness these advanced technologies? The answers may redefine our relationship with the ocean and its untold mysteries. As we explore the vastness of the world's oceans, we often overlook the incredible biodiversity that exists in its depths. In the cold, dark regions of the ocean, life thrives in ways we are just beginning to understand. Ecosystems in these depths exist in complete isolation from the surface world, relying on unique processes that often defy our understanding of life itself. From the vibrant coral reefs to the mysterious bioluminescent organisms, the ocean is a treasure trove of life waiting to be discovered. Recent expeditions have unveiled astonishing new species that adapt to extreme conditions. For instance, scientists discovered a new type of jellyfish, the Deepsteria, which can expand and contract its body to engulf prey effortlessly. Such adaptations challenge our perception of how life can flourish in extreme environments. In addition, new research indicates that microbial communities play a crucial role in maintaining the health of these ecosystems. They recycle nutrients, which sustains larger life forms in this fragile biome. Enhanced studies on these microbes reveal their potential contributions to biotechnology, painting a broader picture of how interconnected marine life truly is. But what about the ocean's role in the global ecosystem? The ocean acts as a carbon sink, absorbing significant amounts of carbon dioxide from the atmosphere and regulating global temperatures. This aspect of the ocean's biodiversity is critical not only for marine species but for the health of our planet as a whole. Understanding these hidden ecosystems could lead to breakthroughs in conservation efforts. However, as climate change accelerates, these delicate systems are at risk. Can we adapt our preservation strategies to save these hidden wonders before they disappear? As we delve deeper, the question arises, how will our actions affect these unknown realms of life? The exploration of the deep ocean has been transformed by groundbreaking technologies that allow us to see deeper and farther than ever before. Innovations in underwater robotics, submersibles, and imaging technologies have revolutionized oceanography and our understanding of marine life. These advancements make it possible to explore the most extreme parts of the ocean without endangering human lives. For instance, remotely operated vehicles, or ROVs, have made significant contributions to deep-sea exploration. Equipped with high-definition cameras and advanced sampling tools, these machines can dive thousands of meters below the surface, capturing stunning visuals of marine life and geological formations. In 2020, an ROV named Alvin was instrumental in discovering new hydrothermal vent habitats, revealing ecosystems thriving in complete darkness and isolation. Additionally, autonomous underwater vehicles, AUVs, have also become critical in mapping the seafloor. Their ability to gather data over large areas efficiently has changed the game for marine scientists. The AUVs can operate over vast stretches of ocean without direct human control, using advanced sonar systems to create detailed maps of the ocean floor. This data is essential not only for studying marine environments but also for understanding geological processes and discovering underwater resources. We've also seen leaps in satellite technology that allows scientists to monitor ocean conditions from afar. Satellites provide invaluable data on sea surface temperatures, currents, and even phytoplankton concentrations. This information is vital for predicting climate change impacts on marine environments and understanding broader ecological changes. As we harness these technologies, the question arises, are we capable of balancing exploration with conservation? How do we ensure that our unprecedented ability to explore does not lead to exploitation of these fragile ecosystems? With technology rapidly advancing, we stand at the precipice of knowing more about our oceans than ever before. The time is now to wield this knowledge responsibly and with foresight. Deep-sea exploration is not just a quest for scientific knowledge, it is a journey into the unknown that has captivated human imagination for centuries. The ocean remains one of the last great frontiers on our planet, filled with mysteries waiting to be unveiled. As we embark on this quest for knowledge, we realize that understanding the deep is vital for our survival and the health of the planet. One of the most significant mysteries of the deep revolves around the phenomenon of deep-sea currents. These are vast underwater rivers that flow in patterns that can influence weather systems and climate around the globe. Researchers found that these currents play a critical role in transporting heat and nutrients throughout the oceans, affecting not just marine life but the entire biosphere. Take, for example, the Gulf Stream, a powerful ocean current. Its influence extends beyond the eastern United States to Europe, bringing warm water and temperate weather. However, studies suggest that climate change may disrupt these currents, leading to extreme weather patterns across the globe. Alongside currents, scientists have also become increasingly interested in underwater volcanoes and how they shape marine landscapes. These volcanoes, found along the mid-ocean ridges, contribute to the creation of new seafloor and can provide unique habitats for diverse marine species. The discovery of these underwater volcanic systems highlights the dynamic nature of the ocean floor and its role in our planet's geological cycles. Moreover, recent research has unveiled complex relationships between marine species and their environments. For instance, the study of fish populations in the Mariana Trench has shown how they adapt to high-pressure habitats, revealing evolutionary marvels that have taken millions of years to develop. This evolving understanding of adaptation and survival in the deep sea emphasizes the importance of preserving these ecosystems for future research. As we continue this quest for knowledge, we must ask ourselves, what will we uncover next? What treasures and truths lie hidden beneath the waves of the ocean? This journey has only just begun, and the ocean's depths hold the key to understanding not only our planet but potentially life beyond it. Deep beneath the waves of the ocean, where light fails to penetrate and darkness reigns, a secretive world thrives. Among its inhabitants resides one of the ocean's most mysterious and magnificent creatures, the whale. The sheer size of these leviathans is awe-inspiring, with some, like the blue whale, reaching lengths of over 100 feet. But despite their immense presence, much about their deep-sea life remains shrouded in mystery. For centuries, humanity has marveled at the songs of whales, intricate melodies that echo through the vast underwater canyons. These haunting calls can travel for miles, yet the purpose behind their symphonies is still a topic of intense study. Experts speculate that these songs may serve various purposes: navigation, communication, or even mate attraction. Let's dive into the enigmatic world of deep-sea whales, exploring their complex behaviors, social structures, and the astonishing discoveries that are reshaping our understanding of these gentle giants. The blue whale, the largest animal to have ever existed on Earth, offers a fascinating glimpse into the life of these oceanic mammals. These creatures can consume up to 4 tons of krill each day, and during the breeding season, they embark on monumental migrations, traveling thousands of miles to find the best feeding grounds. But that's just the surface. In the depths, they engage in behaviors that are still being deciphered. Researchers have documented unusual feeding strategies that involve creating bubble nets to trap prey. This behavior, observed off the coast of California, highlights their intelligence and adaptability to hunting under extreme conditions. However, the story doesn't end with feeding. The complex communication systems of whales have intrigued scientists for years. Recent studies using hydrophones, the underwater microphones, have revealed that different species of whales have unique dialects, much like humans. A fascinating case involved a study of the orcapods in the Pacific Northwest, where distinct sounds identified specific familial groups. The implications of this are profound. It suggests that social interactions among these giants are far more sophisticated than previously thought. As we delve deeper into their world, it's essential to consider the threats facing these majestic creatures. Commercial whaling, ship strikes, and climate change are taking a toll on whale populations globally. The International Whaling Commission has made significant strides in conservation, but the risk of extinction for some species, like the North Atlantic right whale, remains alarmingly high. Recent conservation efforts involving acoustic monitoring aim to protect these endangered whales by keeping shipping lanes clear and understanding their migratory patterns better. In conclusion, with every discovery in the world of deep-sea whales, we unveil not just their lives but also our own understandings of interconnectedness within ocean ecosystems. Will we be able to safeguard their futures as we continue to uncover the secrets of their underwater realm? Join us next as we explore the often overlooked world of the ocean's smallest inhabitants, tiny creatures that play a crucial role in marine ecosystems. Beneath the surface of the ocean, a vast and largely invisible world thrives, teeming with microbial life that is an essential engine for our planet. While we often look to larger marine species for wonder and inspiration, it is these microscopic organisms that play an invaluable role in sustaining the marine ecosystem and, by extension, life on Earth. Did you know that 90% of the ocean's biomass consists of microorganisms? These tiny entities, which include bacteria, archaea, and protists, contribute to carbon cycling, nutrient regeneration, and even climate regulation. One of the most astonishing facts about these microbes is their ability to consume carbon dioxide, a greenhouse gas that contributes to climate change. The process known as carbon fixation can draw down significant amounts of CO2 from the atmosphere, helping to mitigate global warming. Consider the story of Prochlorococcus, one of the smallest and most abundant photosynthetic organisms in the ocean. Discovered in the late 1980s, this microscopic cyanobacterium plays a critical role in producing oxygen and fixing carbon in the ocean's surface layers. Some researchers believe that Prochlorococcus contributes to nearly 20% of the oxygen we breathe on land, making their existence vital for life beyond the ocean. Their adaptability to various light conditions has prompted scientists to study how climate change is affecting their populations. But exploring these microbial communities poses unique challenges. For years, traditional methods of studying marine microbe populations relied heavily on culturing techniques that often failed to capture the vast diversity of microbial life. However, advances in metagenomics, a technique that allows researchers to extract and analyze genetic material directly from environmental samples, have revolutionized our understanding. In a groundbreaking study, scientists collected water samples from the Mariana Trench, the deepest part of the world's oceans. They uncovered strains of bacteria that had never been characterized before, opening a window into the evolutionary adaptations these life forms have developed to survive extreme conditions. These insights not only challenge our understanding of life forms on Earth but also raise questions about the potential for life on other planets with similar extreme environments, such as Europa or Enceladus, moons of Jupiter and Saturn respectively. As we unveil the hidden world of microbes, we also confront the reality of climate change's impact on these essential ecosystems. Ocean acidification, rising temperatures, and pollution threaten the delicate balance of microbial communities. Researchers are racing against time to find solutions that will help preserve this invisible life and, in turn, protect the larger ecosystems that depend upon them. In conclusion, the unseen world of microbial life reveals not only the incredible resilience of these organisms but also the interconnectedness of all life on Earth. Will we continue to cultivate a greater understanding of these microscopic powerhouses, or will their fragility lead to unforeseen consequences for our planet's future? Next, we turn our gaze to the technological advancements that are ushering in a new age of deep-sea exploration. As we venture further into the depths of the ocean, technology emerges as our most crucial ally in uncovering the secrets that lie beneath the waves. Gone are the days when researchers relied solely on submersibles and traditional diving methods to explore the deep sea. Modern innovations are dramatically transforming how we interact with this vast underwater frontier. Let's explore some of the groundbreaking technologies reshaping our understanding of the deep ocean. One of the most exciting developments in recent years has been the rise of autonomous underwater vehicles, or AUVs. These robotic marvels can dive deeper and remain submerged for extended periods, collecting invaluable data without the need for constant human presence. Take the example of the Sentry AUV, developed by Woods Hole Oceanographic Institution. With its ability to map the seafloor in high resolution, it has revolutionized our ability to understand underwater topographies, revealing features that were once thought to be mere shadows on the ocean floor. Another notable advancement comes from the world of imaging technologies. Innovations in deep-sea cameras, such as the remotely operated vehicles, ROVs, have allowed scientists to capture stunning visuals of previously unreachable regions. The use of specialized lights and cameras has brought the colors and forms of deep-sea creatures to life, from the shimmering hues of anglerfish lures to the vivid displays of underwater coral reefs. The infamous Deep-Sea Challenger, piloted by filmmaker James Cameron, demonstrated the potential of such technology, reaching the bottom of the Mariana Trench and returning with high-definition footage that astonished the scientific community. Next, we must consider the role of big data and artificial intelligence in revolutionizing deep-sea exploration. With vast amounts of data collected from various expeditions, researchers are leveraging machine learning algorithms to identify patterns and make predictions about marine life and ocean behaviors. This has tremendous implications for conservation efforts, allowing scientists to respond proactively to the shifts in ocean health caused by climate change. Moreover, the integration of satellite technology plays a pivotal role in ocean exploration. Satellites equipped with remote sensing technology can provide real-time information about ocean conditions, including temperature, salinity, and chlorophyll concentration, which are essential for understanding marine ecosystems. Such insights help scientists track changes and identify trends that might indicate larger shifts in ocean health, better informing conservation strategies. But despite these incredible advancements, the challenge of sustainable exploration remains. As we push the limits of technology, we must ensure that our quest for knowledge does not come at the expense of these fragile ecosystems. Increasingly, researchers are advocating for environmentally conscious methods of exploring the deep sea, aiming to minimize human impact. As we conclude our exploration of innovative technologies in deep-sea discovery, we are left with a question: How will we harness these advancements to protect the very ecosystems we strive to understand? Coming up next, we will investigate the extraordinary discoveries that have changed our perspective on the deep ocean. The ocean floor is a graveyard of ancient relics, where the stories of human history and natural events converge. These submerged artifacts, from shipwrecks to sunken cities, reveal insights not just about our distant past, but about the movements of tectonic plates and climate change. Imagine the remnants of a Roman ship lost to the tides, its cargo preserved in the cold depths. In 1985, Robert Ballard famously discovered the wreck of the Titanic, but that was not the first or the last significant find in the endless expanse of ocean. Dive deeper, and you find the sunken city of Dwarka off the coast of India, an area steeped in myth and legend. It was thought to be a city of gods, but underwater excavations have revealed structures dating back to 7500 BC. Archaeologists are still piecing together how such a civilization thrived and why it disappeared. But why do these discoveries matter? They serve as crucial links to our understanding of historical climate periods. As seas rose and fell, entire societies adapted, migrated, or perished. Consider the ancient ports that once flourished and now lie beneath the waves. The underwater ruins of Alexandria show us how quickly nature can erase the paths of history. The marine archaeologists use advanced sonar technology, remotely operated vehicles, and sophisticated diving equipment to peel back the layers of sediment. Each find, each artifact, offers glimpses into our shared heritage. As we unravel these secrets, we realize the ocean isn't just a body of water, it's a time capsule, preserving our past and holding answers that shape our future. Will we keep unearthing these treasures, or will they remain hidden, left for future generations to rediscover? Beneath the waves, a hidden world exists that is vital to our understanding of life itself, the unseen world of microbial life. These microorganisms, often invisible to the naked eye, serve as the foundation for entire ecosystems. In fact, studies estimate that microbial life accounts for about 90% of the biomass in the ocean. They play pivotal roles, from nitrogen fixation to carbon cycling, impacting global ecosystems and climate regulation. Consider the example of the ocean's phytoplankton. These tiny plants are the ocean's lungs, producing up to 50% of the world's oxygen through photosynthesis. They are also crucial in the food web, serving as the primary food source for many marine creatures, from tiny zooplankton to massive whales. In 2019, researchers on the Terra Oceans expedition uncovered how microbial communities change in response to environmental stressors like temperature and acidity, further emphasizing their importance in climate change discussions. But perhaps the most shocking revelations come from deep-sea ecosystems, where extremophiles thrive. These microorganisms can survive in environments we once thought impossible, at depths of over 10,000 meters, where pressure is crushing and temperatures are freezing. A recent study identified a new species of bacteria at the bottom of the Mariana Trench that not only survives but thrives on sulfur and methane, challenging our understanding of life's resilience. These findings prompt a broader question: what other forms of life remain undiscovered in the deep? As we continue to explore, we might find organisms with unique properties that could lead to innovations in medicine, bioengineering, and environmental science. What are the consequences of losing biodiversity among these microorganisms, and how does it affect larger marine ecosystems? The ocean's unseen world is a vast frontier waiting for us to uncover its secrets. What will we learn next? As we venture deeper into the ocean, innovative technologies are transforming our understanding of this uncharted territory. Technologies such as autonomous underwater vehicles, AUVs, advanced sonar mapping, and remote-operated vehicles, ROVs, are redefining marine exploration. For instance, the Ocean Infinity Fleet, equipped with cutting-edge AUVs, has been instrumental in locating shipwrecks and surveying underwater habitats with unprecedented accuracy. In 2021, they undertook a mission to locate the wreck of the MH370 flight, utilizing these advanced technologies, showcasing their potential beyond just scientific inquiry. But the real story goes beyond finding wrecks. These technologies are being employed to map the ocean floor in remarkable detail. The Seabed 2030 project aims to produce a complete map of the ocean floor by 2030, relying on multi-beam sonar systems that capture high-resolution data. The implications of these maps are profound. They not only help in navigation and resource management but also play a critical role in conservation efforts, identifying vulnerable ecosystems that need protection. Furthermore, satellite technology has revolutionized our ability to monitor ocean health. Instruments like NASA's Sentinel-6 satellites provide data on sea level rise and surface temperatures, crucial for understanding climate change impacts. As we integrate these technological advancements, our ability to explore and understand the ocean deepens. The discoveries made today lay the groundwork for future generations. What else will we uncover? How will these technologies change our approach to ocean conservation and exploration? The quest for knowledge is endless, and as we look to the future, we must ask, what mysteries remain to be solved? Beneath the waves, a world of mystery awaits, home to some of the largest and most enigmatic creatures on the planet, deep-sea whales. These majestic giants, often cloaked in mystery due to their elusive nature, represent a fascinating aspect of the oceanic ecosystem that remains largely unexplored. Imagine a creature weighing as much as 200 tons, with a heart the size of a small car, swimming gracefully in the abyss. One of the most compelling stories comes from the depths of the Southern Ocean, where researchers have made groundbreaking discoveries about the blue whale. With lengths of up to 100 feet, blue whales are the largest animals to have ever existed. But their size is not the only aspect that captivates researchers, it's their songs that resound across the ocean, communicating over vast distances. In a recent study, scientists recorded these vocalizations, revealing a complex pattern of communication that hints at a sophisticated social structure far beyond what was previously understood. Not only do these songs serve a communicative purpose, but they also play a crucial role in navigation. Researchers believe that these whales might use their songs to echolocate in pitch-black waters, transforming sound into a navigational tool. Yet, despite their imposing size and capabilities, blue whales face numerous threats, including ship strikes and climate change. In another intriguing tale, we delve into the world of sperm whales. Known for their deep diving abilities, sperm whales can plunge to depths of over 10,000 feet, hunting giant squid in the dark confines of the ocean. The relationship between these whales and their prey has sparked curiosity among marine biologists, as they've uncovered evidence of deep-sea battles fought in the murky depths. The technology of the modern era allows for unprecedented insights into these creatures. Tags like the use of advanced sonar technology have enabled researchers to monitor their behavior in ways that were unimaginable just a few decades ago. A prime example is the use of tagging devices, which track the movements and feeding habits of whales. One noteworthy project off the coast of California has revealed migratory patterns that stretch across oceans, giving researchers insights into how these animals interact with different ecosystems. As we come to a close in this exploration of deep-sea whales, it is crucial to acknowledge the collaborative efforts between scientists and conservationists. Their research is not just about understanding these creatures, but also about advocating for the protection of their habitats. As awareness grows regarding the threats facing these giants, initiatives to protect their migratory routes and feeding grounds are more essential than ever. In the heart of the ocean, blue and sperm whales symbolize our planet's magnificence and fragility. Their continued survival hinges on a collective commitment to protecting their underwater domain. What other secrets lurk in the depths of the ocean, waiting to be uncovered? With every dive, we inch closer to understanding the intricate tapestry of life beneath the waves. When we think of the deep ocean, we often envision gigantic creatures, sweeping currents, and dramatic landscapes. But what lies beneath the surface, in the realms where light cannot penetrate, is perhaps the most astonishing and crucial component of our planet's ecosystem: microbial life. These microscopic organisms, invisible to the naked eye, form the foundation of the marine food web and play a critical role in global biogeochemical cycles. Recent studies have unveiled the staggering diversity of microbial life in these depths. In one groundbreaking expedition to the Mariana Trench, researchers discovered new species of microbes that thrive in extreme conditions, such as high pressure and low temperatures. These extremophiles challenge our understanding of life and its resilience, showcasing nature's ability to adapt and flourish in the most inhospitable environments. Microbes are not just survivors, they are vital players in carbon cycling. Through a process known as microbial respiration, they decompose organic matter that sinks from the surface, returning nutrients back into the ocean ecosystem. In fact, recent estimates suggest that microbial processes account for up to 90% of the ocean's carbon cycling. This discovery highlights their importance in regulating climate and maintaining ecological balance. Imagine a world without these tiny warriors. Carbon levels would skyrocket, leading to devastating impacts on marine life and, ultimately, our atmosphere. Moreover, scientists have recently identified that these microbes are engaged in a complex web of interactions with each other and larger marine organisms. Through symbiotic relationships, they aid in nutrient absorption for fish and invertebrates, illustrating a fundamental connection between microscopic and macroscopic worlds. For example, certain coral species rely on specific microbial communities for health and survival, a phenomenon that is termed coral holobionts. The implications of these microbial discoveries extend beyond ecological understanding. They hold potential for biotechnology in various fields, ranging from pharmaceuticals to biofuels. For instance, compounds derived from deep-sea microbes are being researched for their potential use in developing new antibiotics, which could revolutionize medicine. The search for novel bioproducts from these organisms is just beginning, and as technology advances, who knows what medical breakthroughs await us. Yet, the future of these microbial communities faces threats from climate change and pollution. As ocean temperatures rise, the delicate balance of these